The sun will have a fate such as this, where at the end its outer layers of gas will escape into space. For the sun, this is how it will end. The gas on the outside will escape into space. People have always been interested in the stars, but it's only been in the last few years that we've started to understand galaxies, which are huge groups of stars at the far ends of the universe. Everyone thought the Webb telescope would be a big deal in the field of science, and we were sure Webb would amaze us with something incredible. However, its most recent results have been even better than we thought they would be. Neil deGrasse Tyson, an American astronomer, says that the Webb telescope has given us a look at ghosts from the past. What amazing things have the telescope shown us about the universe that we couldn't see before? How does this new picture make you feel? Let's find out. Since its startup in the summer, the James Webb Space Telescope has shed new light on some of the most amazing discoveries made in space. Recently, the Webb team used the telescope's infrared vision to see through Titan's thick atmosphere and found what they think is a methane sea, sand dunes, and clouds. The $10 billion telescope has also taken stunning pictures with amazing depth and vivid color. These pictures show the stellar nurseries of the Carina Nebula and some of the first galaxies that formed less than 500 million years after the Big Bang. The head of the Hayden Planetarium in New York, Neil deGrasse Tyson, said that people didn't expect too much because so many things had to go right. He told Fox News Digital that it met all of the design requirements, which was more than expected. Tyson said those pictures make it clear that we are in a new era of astrophysics. With the Hubble telescope and now the James Webb Space Telescope, we have opened a door to a view of the universe that was previously out of reach. Tyson said that people can't see in the ultraviolet part of the spectrum, but the Hubble Space Telescope can. He explained that telescopes are tuned to see different bands of light in the world. The famous scientist said that the James Webb Space Telescope changes colors so that people can see them in pictures taken with it. Tyson says that the brain makes a picture by putting together 3 bands of light and giving each one a color, which is a lot like how computers use RGB coding. This can be done with any 3 bands of light, no matter where they are in the spectrum. There are a lot of infrared pictures that show galaxies that were hidden by clouds or dust before. In deep-field pictures, you can see tiny dots of light along with beautiful spiral galaxies. But the question came up, when scientists study galaxies from before the universe was 1 billion years old, are they looking at some of the earliest or oldest galaxies on record? The light you see from the most distant galaxies is the oldest light in the universe, the oldest light from stars in the universe, Tyson stated. It has been traveling for 13 billion years, so in that sense, it's the oldest because it's coming from the newest galaxies. Every picture that Webb has sent back from the early universe is stunning. It says that the telescope was built specifically to pick up infrared light. There was a hole in the fabric of space and time that kept everything on Earth from getting good information from the early universe. This is because UV light is released when stars and galaxies are being formed, but as the light waves move through space, which has been expanding since the Big Bang, they get longer. Tyson says that by the time it gets to us, it's infrared. So far, Webb has seen galaxies that were made more than 13 billion years ago. It has also changed how we think about the worlds in our own solar system. It's a portal through which we've been transported to a new era of high-resolution, high-quality data in modern astrophysics, Tyson says. How do you explain the fact that we can see things in space that happened a very long time ago? Are they still alive if it took millions or billions of years for their light to reach us? The universe is very big. Even though light moves at 299,792,458 meters per second, the new pictures from the James Webb Telescope might change how we think about how the world began. It's like the fingerprint of all the chemistry that's going on in there, according to Neil deGrasse Tyson. It also tells us about the chemical elements and how they fit into the picture of how the universe grew. Recently, after the White House only confirmed a few facts about flying objects that couldn't be explained, rumors started to spread that the objects were made by aliens. Since then, the White House has said again that there was no proof of aliens or action from other worlds, but it hasn't given any more information. The James Webb Space Telescope has also helped astronomers learn about the past of the universe. They have found huge galaxies that shouldn't be there, which was a surprise. No one was ready for them. Deep field pictures from the James Webb Space Telescope's first observation campaign show galaxies that are almost as big as the Milky Way and are full of adult red stars. However, astronomers are having trouble finding these galaxies. These galaxies are so far away that the strong telescope can only make out small red dots that make them look like stars. They were found in a new study that used Webb's first set of data. By looking at the light these galaxies gave off, astronomers found that they were only 500 to 700 million years after the Big Bang. These very old galaxies are not a surprise in and of themselves. In the first 400 million years of the universe's life, when space was filled with nothing but hydrogen atoms, these galaxies have shown us more than we thought possible. It was thought by astronomers that the first star groups would form soon after the universe came out of the Dark Ages. The Webb pictures, on the other hand, showed stars that were too old and the galaxies were incredibly big. The newest finds don't match up with observations made by the Hubble Space Telescope, which was less powerful than Webb. They also don't match up with commonly held beliefs about how the universe formed and changed in its early stages. As assistant professor of astronomy and astrophysics at Penn State Joel Leah, who wrote the study, put it, "We thought that the galaxies that live in the early universe would be a certain way. They are little and young. During Hubble and other tool studies of the early universe, small blue galaxies are often found. These things are still building their own early stars and structures after just emerging from the primordial cosmic soup. The light from young stars is usually blue. Stars age and turn red as they cool down and use up their fuel. Webb was made to find galaxies far away, but astronomers were shocked to find red stars that were so old in them. In the same way, they weren't ready to find galaxies with masses bigger than a billion suns. However, the red spots seen in Webb's deep fields look 50 times bigger than that. Leah said that the galaxies in her group that were the heaviest were only 2 to 4 times as heavy as the Milky Way. We're discovering galaxy candidates that are as large as our own galaxy when the universe is only 3% as old as it is now, said Leah. Before cosmologists change their ideas about how these galaxies formed so quickly after the Big Bang, they need to be sure that the strange red spots they see are not something else. On the other hand, most of the other answers also need new ideas. Leah says that because stars in the early universe didn't have any heavy parts, they might have made light in strange ways that we aren't taking into account in our models. On the other hand, it's possible that the local star formation processes we know about, for example, how many stars form from gas and how much mass they have, didn't matter at all in the early universe. These findings would likewise be thrilling and, in a totally different way, challenge our knowledge of how stars emerged in the early cosmos. Webb's near-infrared camera, NIRCam, took pictures of these strange galaxies as part of the Cosmic Evolution Early Release Science (SEWERS) program. Soon, scientists will point Webb's mirror back at these galaxies to learn more about the light they give off. Spectra break down incoming light into its individual bands, which show the chemical and physical properties of the light source. Scientists are already being pushed to change what they think about the early universe, and this is only a few months after the Webb team released the first results from their huge observatory. The huge galaxies don't match up with 99% of models of the universe's first galaxies. This means that scientists have to rethink their ideas about how galaxies form and change over time. Also, that's not all the James Webb Telescope has to offer. The more we learn about Stephan's group of 5 dark angels, the more we see that this part of the world is just as big and scary as it seems. Astronomers said at the annual meeting of the American Astronomical Society that more research with the James Webb Space Telescope and the powerful Atacama Large Millimeter/Submillimeter Array ALMA has shown that these 5 beautiful galaxies are in a state of pure chaos. First, NGC 731b, also known as the Intruder, is moving into the space between the other 4 galaxies and making a huge shock wave the size of many Milky Ways. A very strong wave has set off a recycling machine for clouds of warm and cold molecular hydrogen gas between the 5 of them. This is causing a lot of trouble. Bjorn Amons, an astronomer at the National Radio Astronomy Observatory and a co-investigator on the experiment, said in a news release, "It may be rare and not fully understood yet for a molecular cloud to cut through intergalactic gas and cause chaos in its wake. We have learned more about the strange behavior and rough life cycle of molecular gas clouds in Stephan's quintet, though. Based on our data, even stranger, the researchers found a huge bundle of gas next to the group that was slowly breaking apart as a separate tail of hot gas formed nearby. To sum up the last part, this tail could mean that the galaxy is young. At this end of the world, which is luckily between 39 million and 340 million light-years away, there is a rough sitcom going on with more than one character. One of the galaxies is a lot closer than the ones in the center that are dancing most of the time. Shock waves are made when an object moving faster than sound through a gaseous medium hits something, like Stephan's quintet. In this case, the object is NGC 731b, and it is hurtling through space at an amazing 800 kilometers per second, which is almost 500 miles per second. The press statement said that at that speed, the trip from Earth to the Moon would only take 8 minutes. Philip Appleton, an astronomer at Caltech and co-author of a report on the findings, said that in 2006, Spitzer helped their team find an amazing fact. Scientists found a huge number of specific hydrogen molecules giving off infrared light within the shock wave, along with X-ray emissions that are normally thought to be pure. When these kinds of things happen, Appleton says, these molecules usually wouldn't be able to handle shock waves moving at speeds of more than 30 to 50 kilometers per second. As a result, the team had to ask, what's going on here? This brings us back to the real chaos we were talking about before. Appleton explained that the gaseous medium this shock wave is hitting is clumpy. As the shock moves through space, these clumps seem to break up into smaller clumps called cloudlets. It is these tiny cloudlets that are giving off the questionable hydrogen. After that, the hydrogen joins the shock wave itself. To put it another way, it looks like the hydrogen in the area is recycled by the warm and cold gas that is around the shock wave. During their 2006 watch of the wave, the team found all that hydrogen that had been restored. In the news release, Appleton said, this is significant because molecular hydrogen is the building block that may eventually form stars. So understanding its fate will tell us more about the evolution of Stephan's quintet and galaxies in general. Because of the recycling state, all of this crazy activity also creates what Appleton calls unexpected structures. As the shock wave moves through its clumpy obstacles, a thread of hot molecular hydrogen gas links two cold clouds that are shaped in an odd way. Picture a bullet moving quickly through a cloud and leaving a ring-shaped trail behind it. The other is a shape that looks like the tail of a new galaxy. What we're seeing is the disintegration of a giant cloud of cold molecules in a super-hot gas, said Appleton. Interestingly, it just cycles through warm and cold phases. We are still learning about these cycles, but we can guess that the gas is being reused since the tail is longer than the time it takes for the clouds it is made of to disappear. In the future, the team wants to use spectroscopic studies to exactly follow the movement of all the gas around the shock wave. In this way, it would be possible to see how fast the gas is moving and how it is being heated or cooled as the shock wave pulses through the area. These new findings have helped us understand things better, but they have also shown us how much more we need to learn. To be honest, we only have one side of the story. It's time to get the other one. Now, deGrasse Tyson has said that if he had the power to direct the James Webb Space Telescope, he would point it at an unknown point in the universe. This way, he says, it would be able to find things and answer questions we don't even know to ask without being guided by what we think it should find. As the James Webb Space Telescope continues its groundbreaking work, astronomers are unveiling more about the structure and evolution of the universe. With its advanced capabilities, Webb is giving scientists a new perspective on how galaxies, stars, and even planetary systems are born. The telescope's infrared technology allows it to penetrate dust clouds and observe distant cosmic events that were previously impossible to detect. One of the most exciting aspects of this mission is that it is providing clues about the early stages of the universe, helping us understand how stars and galaxies formed just a few 100 million years after the Big Bang. The unprecedented resolution of Webb's observations is also revealing previously hidden details in the formation of stars. In some regions, Webb has uncovered intricate patterns of star birth within nebulae, regions that are known as stellar nurseries. These observations are key in helping scientists understand how new stars are created, how they evolve, and how they influence the surrounding environment. Additionally, the data from Webb are pushing our understanding of dark matter and dark energy, two of the most mysterious components of the universe. Though these phenomena remain largely unseen, Webb's findings are beginning to shape our models of the cosmos and its fundamental forces. Webb's study of exoplanets has also provided new insights into the potential for life beyond Earth. By analyzing the atmospheres of distant planets, scientists can now detect the presence of elements like oxygen, methane, and carbon dioxide, key markers for habitability. This could help astronomers identify planets that may harbor life, giving humanity a closer look at the possibility of extraterrestrial life in our galaxy. In essence, the James Webb Space Telescope is not just a tool for studying distant galaxies, but a transformative instrument that is reshaping our entire understanding of the universe. Each new discovery brings us one step closer to answering some of the biggest questions in science and unlocking the mysteries of our cosmic origins.